Hi everyone, welcome to Maths Power. This video is about recurring deposit account, which is also called as cumulative deposit account. So what do you mean by this recurring deposit account? This account is an account in which an investor deposits a fixed money in multiples of 5 rupees for a period of fixed time in multiples of 3, that is quarterly, half yearly, annually. At the end of the maturity period, he receives the money deposited by him every month plus the interest accrued on that month after month. Let us see how do we calculate the interest and how do we get the maturity amount in recurring deposit account. Let us look at an example. If an investor decides to deposit 100 rupees in a recurring deposit account for a period of half year, that is a half year, and the bank allows a rate of interest as some 10%. First thing to do is change the time from years to months, that is N is 6 months. Then you see first month the investor is depositing 100 rupees. Second month this 100 is already existing. To this another 100 rupees he has deposited. Third month these 200 rupees are already there. Then to this he is adding another 100. And in the fourth month already 300 rupees are there in the account. He is depositing another 100 rupees. Then fifth month 100, 100, 100, 100. 400 rupees are already there. He is depositing another 100 rupees. Then sixth month he is depositing another 100 rupees to add on to the 500 what was already existing. Now if you have observed this, at the end of first month he will get the interest on 100 rupees. At the end of second month he will get the interest on 200 rupees. At the end of third month he will get the interest on 300 rupees. At the end of fourth month he will get the interest on 400 rupees. At the end of fifth month he will get the interest on 500 rupees. At the end of sixth month he will get the interest on 600 rupees. Now on the whole, if you see, he is getting the interest on 100 plus 200, 300 plus 300, 600 plus 400, 1000 plus 500, 1500, next another 600, that is rupees 2100. So on this amount, on this money, this particular investor is getting the interest. So this particular figure, that is rupees 2100, is called as equivalent principal. Equivalent principal. How do we find this equivalent principal? Will the investor get this 2100 rupees into his hand? No, because how much money he has deposited on the whole every month 100 rupees he has deposited. So 6 months, every month he has deposited 100 rupees. So he deposited only 600 rupees. He deposited only 600 rupees. But on this equivalent principle, the interest is calculated. In what way it is calculated? Equivalent principle can be found by using a formula that is n into n plus 1 by 2. N into n plus 1 by 2 states sum of first n natural numbers. This multiplied by the principal means the monthly deposit. So here 6 into 6 plus 1 by 2 into 100 rupees, that is 2 ones, 2 threes, so 3 into 7 into 100, this is 2100 rupees. Then how are we going to calculate the interest? So interest will be found on equivalent principle. Equivalent principle is n into n plus 1 by 2 into p, which is totally considered as principal because on this we are finding the interest. T, time, PTR by 100. We are all aware of finding the simple interest by using PTR by 100. So here P is equivalent principal, then time, every month you are finding the interest, so 1 by 12. Then R by 100, that is rate of interest by 100. So PTR by 100. Then here this value, as you know, as 2100 into 1 by 12 into R by 100. R we assumed as 10 by 100. So now 0 0 0 0 will get cancelled. 3 sevens, 3 fours, 2 twos, 2 fives. So here it is 35 by 2, which is 17 rupees 50 pies. 17 rupees 50 pies. So this is the interest. Then how do we find the amount what the investor will receive at the end of or at the time of maturity of this recurring deposit account? Maturity amount is number of months multiplied by monthly deposit plus interest, that is number of months 6, monthly deposit is 100 rupees, so he has deposited 600 rupees. Every month he has deposited 100 rupees, so in 6 months he deposited 600 rupees. On this he has to get the interest. So interest received is 17 rupees 50 pies. So at the time of maturity of his recurring deposit account, he will receive 617 rupees 50 pies. Don't be under the confusion that equivalent principle is going to be added at the time of maturity amount, which is absolutely not correct. So we need to remember 3 formulae to find the recurring deposit account solutions. First one is equivalent principle, that is n into n plus 1 by 2 into P, where n is number of months, very important. P is monthly deposit or monthly installment. Then second formula is for finding interest, that is n into n plus 1 by 2 into P, which is equivalent principal, into 1 by 12 into R by 100, where R stands for rate of interest per annum. Then finally maturity amount, that is number of months into monthly deposit plus I. So in some questions, in place of this I, you can replace this complete n into n plus 1 by 2 into P into 1 by 12 into R by 100 formula to solve the solution at a time. Thank you.